Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Welcome back to our machine learning class. In this part, we'll go on to learn random forest algorithms. Random forest is an integrated learning model, and let's quickly move on to what is integrated learning model. Let's break down the concept of ensemble learning. Ensemble learning is a technique that involves using multiple independent base learners to learn from data. Think of these base learners as students in class, who each have their own ways of solving problems. Ensemble learning combines their individual solutions to come up with the better answers using a specific strategy. Instead of relying on just one student, you create a set of rules for each student to follow. These students provide their own answers, and then they use special method to combine all their answers into one final solutions. Here is how it works. First, we create a group of students by giving them a specific rule to follow. And then, each student give their answers to a problem. And finally, we don't just pick one student's answers. We use a special way to merge all their answers together and come up with the best possible answers. It's like having a team of students working together to solve a problem. And their combined effort often leads to more accurate solutions. So, when we're talking about ensemble learning, it's all about picking the right team of learners
and then using the effective strategies to
turn them into a super smart learner. You see, if we relying on just one learner, they might get a bit too bossy and make model not too so good and handling new stuff. But if we bring a bunch of different learners,
they can team up and make our model way smarter.
Ensemble learning is like a superhero team that tackles these three main problems. The first is figuring out how to make those individual learners in first place. And second, making sure each of those best learners is really good at their job. The third is having a cool method for putting together all smart answers from these base learners. Now, here are two big questions we need to answer for ensemble learning. The first is, how can we efficiently train a bunch of base learners? Think of it like getting a group of students up to speed without wasting too much time. A second is, what's the best way to mix up all the smart things these base learners know into one smart learners? It's like blending different ingredients to make the perfect smoothies. There are two main ensemble model strategies. The first is averaging strategies. This is like training each model as an independent player. They each provide their own answers, and then we make the average of their answers as the final output. It's similar to asking a group of people a question and taking their average opinions as this is the answer. The second is boosting strategies. This is a progressively improving method. First, we have one model make predictions, and then we examine the difference between its predictions and the actual outcomes, which is called the residual. Next, the next model tries to correct the mistakes made by the previous model, and then make the predictions, continuing to reduce the residual. This process continues, with each attempt trying to get closer to the real outcomes than the previous one. until we eventually obtain a more accurate final output.
It's like mastering a new skill, constantly correcting errors and
Gradually becoming better at it. Homogeneous individual learners can be categorized into two groups depending on their presence of interdependencies among them. The first is strong dependencies. In cases where there is a strong dependencies among individual learners, representative algorithms include boosting algorithms such as AdaBoost and Charging Boost. No strong dependencies. There's no strong dependencies among individual learners.
These learners can be generated in parallel.
The representative algorithms for these scenarios is random forest algorithm. Heterogeneous ensemble models. Heterogeneous ensemble models are created by combining individual learners of diverse types. Bootstrap resampling. In statistical resampling techniques, a notable approach is the bootstrap method. The bootstrapping method entails the following steps. First, random resampling. Randomly select examples from the original training sample set, where n is the size of the original dataset. Importantly, this selection is done with replacement, allowing for possibilities of duplicate samples in resampled datasets. Repetition is independently repeated k times, resulting in k mutually independent bootstrap sample set. In the case of random forest, the final classification is determined through a vaulting mechanism involving multiple trees. This voting process aims to find a consensus among the individual classifiers. Here, let's look at the bagging examples of integrating strategies. There is a set of statistical data on age and annual income as shown in the table. Try to use the bagging ensemble learning method to construct a train sample set for random forest. Now here, we use the resampling method. We can get the 3 training samples. And let's move on to the basic ideas of random forest. By utilizing the bootstrap resampling technique, training and testing samples are repeatedly generated. A random forest consists of multiple classification trees generated from the training samples. The classification result for the test data depends on the number of votes from classification trees. Random forest has 2 important parameters. The number of features attribute preselected for each tree node. Another is the number of trees in the random forest.
the base learner of a random forest are dices and trees.
For an input sample, if there are n decision trees, there will be n classification results. Random forest integrates all the classification voting results and selects the class with the highest vote count as the final output. As the process of random forest, first, we should sampling to generate a training dataset for each decision tree. Random forest employs bagging sampling to generate n training subsets from the original training datasets. Second, constructing n decision tree is a decision tree is built for each training set, resulting in n decision trees forming the forest. Each decision tree is built without requiring pruning. Third, generating the random forests and making classifications. The random forest is generated, and the classification of a given sample is determined based on the majority vote principle.
For classification of test examples,
The random forest employs n decision trees, and their results are aggregated using the majority vote principle to decide the categories for the sample. And force, randomly generating n training subsets from the original training set. Here, n training subsets are randomly generated from the original training set for the purpose of creating n decision trees, and fives, randomly selecting
m attributes.
during the constructions of individual decision trees. Here during the construction of each decision tree, a randomly selections of m attribute is made. The incorporations of these two sources of randomness in the process of generating the random forests ensures that overfitting is mitigated. Here we have schematic algorithms for the random forest algorithms. First, we generated key subsets from the original datasets, and we use each subset to create decision trees. And finally, we sums up these decision trees and averages our output to make the best vote as our output. Table 5.6 is a dataset for diagnosing code, using the dataset to construct a CART decision trees that serve as weak learners in random forests. When determining the splitting attributes for a certain node, if the attribute set corresponding to that node has own features, it is specified that a random selections of ACE attribute will be used to calculate the Gini index for determine the splitting attributes. Here we left the calculating process as the homework for you to do after this video. And I want you guys to construct random forest and with the basic decision trees as we learned in the previous lessons. You can check whether your answer is right and at the end of this presentation. So this concludes all our today's course. We introduce the integrated learning concepts and simply introduce the typical random forest algorithms for you guys. So see you again in the next lesson.